The history of civilization is, at its core, a history of energy. From the discovery of fire to the splitting of the atom, our progress as a species has been defined by our ability to capture, store, and manipulate the fundamental forces of nature. But as we look toward the horizon of the next 1,000 years, we are forced to ask, is there an upper limit to our development? Or is the universe a playground of infinite energy waiting for a civilization sophisticated enough to claim it? Welcome to Apex Inquiry. Today, we are not looking at the Kardashev Scale as a piece of science fiction. We are examining it as a rigorous framework of astrophysics. We are going to analyze the energy requirements, the material limitations, and the thermodynamic realities of a civilization that spans from a single planet to the vast, cold reaches of the galactic core. To understand the scale, we must look back to 1964. The Soviet astronomer Nikolai Kardashev published his seminal paper, Transmission of Information by Extraterrestrial Civilizations. He was not merely interested in aliens, he was interested in the mathematical inevitability of technological growth. Kardashev proposed that civilization is measured not by culture, but by Kardashev's metric, the total power consumption of the society in watts. This is grounded in the laws of thermodynamics. Think of entropy. As a civilization advances, it must increase its energy throughput to organize itself against the relentless march of entropy. This is the fundamental physical law that dictates why a Type 1, Type 2, or Type 3 civilization must exist or die out. In this hour-long investigation, we will strip away the myths. We will look at the scale through the lens of pure, peer-reviewed physics. We move from the energy we consume today to the theoretical limits of existence. Let us begin by dismantling the framework of the scale, starting with our own position, the Type 0.7 stage. Let us look at our present state. Based on modern energy consumption data, humanity sits at approximately Type 0.73 on the Kardashev scale. This is what we call Energy Adolescence. We are extracting about 18 to 20 terawatts of power annually. However, our reliance on fossil fuels, stored sunlight from millions of years ago, is creating a thermodynamic imbalance. From an astrophysical perspective, the challenge is not just sourcing energy, but managing the heat rejection and environmental stability of our planet. We are currently struggling to transition to a global, sustainable grid without destabilizing the very biosphere that supports us. The leap to Type 1 represents the first milestone of a true planetary civilization. This requires controlling the total incident solar energy reaching Earth, approximately 10 to the power of 17 watts. To achieve this, humanity must master global fusion energy, advanced photovoltaic integration, and, perhaps most importantly, weather and climate engineering. A Type 1 civilization would treat the Earth as a single, integrated machine. This is not about conquest, but about homeostasis. It is the ability to regulate planetary scale systems, ensuring resource abundance, water availability, and extreme energy efficiency. But there is a catch. The path to Type 1 is fraught with the risk of the Great Filter. The technological power required to reach Type 1 is identical to the power required for mass-scale environmental or nuclear destruction. This is the core scientific tension of our century. We have analyzed our own standing. Now we must look upward, at the scale of the stars and the theoretical engineering required to harness them. We now enter the realm of stellar engineering. A Type 2 civilization does not just live on a planet. It commands the entire energy output of its host star, roughly 10 to the power of 26 watts. The concept of a Dyson swarm is often discussed, but let us look at the physics. Constructing a megastructure around a star requires a level of material science that surpasses current planetary manufacturing by orders of magnitude. It would require the dismantling of entire planets to create a shell of solar-collecting satellites. From an engineering standpoint, this is an exercise in orbital mechanics and photon pressure. How do you stabilize millions of individual satellites orbiting a star? It is a problem of immense complexity, where the structure must be kept from spiraling into the star due to gravity or being blown away by stellar wind. Beyond the star lies the galaxy. A Type 3 civilization taps into the energy of billions of stars, 10 to the power of 36 watts. This is the scale of astroengineering that defies modern imagination. To govern a civilization of this size, communication delays become the primary enemy. Even at the speed of light, it takes 100,000 years to cross the Milky Way. A Type 3 civilization must operate through decentralized autonomous systems or perhaps wormhole-based communication networks that utilize exotic matter. We are moving into a domain where the laws of general relativity dictate the limits of governance. Maintaining cultural, political, or even biological coherence across 100,000 light-years is a challenge that requires a fundamental rewrite of information theory. It is not just about having the power, it's about managing the infrastructure of a galaxy-spanning network. We have now analyzed the boundaries of what is physically theorized. Next, we must confront the speculative fringes and the silent question that haunts our search for these civilizations. Beyond the galactic scale, we encounter the speculative tiers, types 4 through 7. While mathematically enticing, these tiers move into the realm of speculative cosmology. They posit civilizations that manipulate space-time constants, dark energy, and parallel realities. However, we must state clearly, these are currently far beyond the reach of testable, observational science. They represent the upper bounds of mathematical logic rather than empirical observation. In our search for life, these levels remain theoretical playgrounds, reminding us that there is a vast gap between what mathematics allows and what the physical universe provides. This brings us to the most haunting question of all. If the Kardashev scale is a map of potential progress, where is everyone? The Fermi paradox asks, if intelligent life is common, why does the universe appear so silent? This is the great filter. It suggests that most civilizations destroy themselves before they reach the stars. Perhaps the jump from Type 0 to Type 1 is a barrier that few species can cross without falling victim to their own technological trajectory. As we conclude our investigation, we look back at our own planet. The Kardashev scale is not just a ladder to the heavens, it is a mirror reflecting our own maturity. Our future is not guaranteed by the scale, it is earned by the decisions we make in this century. I am Basil, and this has been a scientific deep dive by Apex Inquiry. We seek the truth through evidence, rigorous analysis, and the pursuit of fundamental understanding. Thank you for joining us on this inquiry into the limits of existence. Stay curious and continue to question the fundamental reality of our universe.